questions 21 through 25 on the 2008 grade 12 AMC 12B. Two circles of radius 1 are to be constructed as follows. The center of circle A is chosen uniformly and at random from the line segment joining 0, 0 to 2, 0. The center of circle B is chosen uniformly and at random and independently of the first choice from the line segment joining 0, 1 to 2, 1. What is the probability that the circles A and B intersect? First, let's draw a basic diagram to illustrate what this looks like. So here is the basic illustration. As always, I am going entirely by the question stem. This is 0, 0. This is 2, 0 right here. And then the other circle, its center will be anywhere from 0, 1, which is right here, to 2, 1, which is right here. So what I've done is I've put them in certain positions initially just to sort of talk about this, and then we'll proceed with the question. So the first circle has center A anywhere between these 2 points. So what I've done is I've just put it at the origin, making that A. And the second circle has center B anywhere from these 2 points. So I've done that in the following way, just put B right there. Now, as you can see, these 2 circles do not intersect, correct? So what we want is a situation where the circles intersect or at least are touching. So something like this. As you can see, now these 2 circles are touching. And that basically is the very beginning of intersection. First they touch, and then they start to intersect. And if they're tangent to each other, then that is included as an intersection. Or at least part of the same group in terms of our question. They're not separate. So what that basically means is that the circles have to have centers that are within 2. So for example, if you look at the 2 centers of these circles, the first center is here. A used to be over here, right? But then I shifted that circle a little bit to make it touch the other one, and therefore A is now here. And now look at the circles. Their centers are between a 2, exactly 2 in this scenario, because the radius is 1 for this circle right here, and the radius for this circle is also going to be 1. And they tell you that in the question also. So this distance from A to B is 2. This is 1 and this is 1. So long story short, the conclusion is that the circles will intersect if the distance between the centers is less than or equal to 2. And that distance, I'll just call it D, and D has to be less than or equal to 2. And if it is, the circles will intersect. So what I will do is, instead of giving this an absolute point, I will just call it a certain coordinate. I'll just call it B1, right? Because it's going to always be along this line, so the y coordinate is always going to be 1. And that's why we know it's B1, B representing some x coordinate. And then this circle right here, instead of giving it an absolute value, I will give it just A0 as the coordinates. Because it's always going to be along that line, the y coordinate will be 0. The x coordinate I'll label as A. So now I have to figure out the distance from A to B. And using these 2 points, I can create a little formula. And using the distance formula, which is B minus A all squared plus 1 minus 0 all squared under the square root sign, and that distance has to be less than or equal to 2. If you square both sides, you get B minus A squared plus 1 is less than or equal to 4. That means B minus A squared is less than or equal to 3. Taking the square root of both sides, I get B minus A is between positive root 3 and negative root 3. All right. So far, I hope you are following. No tricks so far. Now, A and B, we have to create an understanding that they have a certain boundary, right? A, this guy right here, is anywhere between those 2 points. So A lies between 0 and 2, right? And similarly, B is between those 2 points, and B is also between 0 and 2. So that's going to be important when we try to figure out a probability, which is what they want. So now where do we proceed from here? Now what we have to do is try to figure out, with these boundaries, what is the probability that b minus a will be between positive root 3 and negative root 3. But how do we do that? We use an interesting method that may seem a little abstract at first, but it serves the purpose. Is that you plot a and b on a coordinate system like this. So I'll call this A and I'll call this B, like that. And we'll just label it, I'll call this 2, and root 3 is approximately 1.7. So I'll place root 3 approximately here, root 3, like that. And similarly on the other side, I will label 2 and root 3 for B. Now, my task is to figure out this right here. When is b minus a between root 3 and negative root 3? So I have to draw a full square for the complete boundaries of a between 0 and 2 and b between 0 and 2. So what represents this right here? That is represented by the following. It's a region that lies in between those two lines right there. So that is the region that represents this inequality. And if we can find the area of that region and divide it by the area of the full square, we will get our probability. So here we go. So our probability, therefore, is area of the shaded region divided by area of that square. The area of that square is fairly straightforward. It's just a 2 by 2 square. So there we go, 2 times 2. Now the area of the shaded region is, of course, the full square, which is 4. Subtract these two little triangles right there. So those two triangles I have to subtract. So 2 times 1/2 base times height. But the base and height are fairly straightforward to figure out. It's just 2 minus root 3. 2 minus root 3. And that represents the base and the height, since those are isosceles triangles. So there we go. That's the math. And let's simplify this now. So we've got 4 times, this looks like just 1, so I just have to expand that. So it's going to be 4 plus 4 root 3, right? Because I have to take it out of this negative. And then negative 3. And at the bottom, I've got 4. So this just simplifies to 4 root 3 minus 3 over 4. 4 root 3 minus 3 over 4 is the answer. And that would be choice E. A parking lot has 16 spaces in a row. 12 cars arrive, each of which requires 1 parking space, and their drivers must choose their spaces at random from among the available spaces. Auntie M, that then arrives in her SUV, which requires 2 adjacent spaces. What is the probability that she is able to park? Just as an aside, Auntie M sounds very familiar, and I realized why. Any of you have ever seen the movie The Wizard of Oz? It's a classic movie that I saw when I was a boy. It's from 1939, and Auntie M is actually a character in that film. I'm pretty certain that the people who wrote this question know that. Otherwise, that'd be a pretty big coincidence. It was played by an actress named Clara Blandick, and she passed away many years ago. But of all the numerous movies that she's been in over the years, this Auntie M was the most famous role that she ever did. All right, now that we've talked about NTM, let's move with the question. Okay, so we've got 16 parking spots, right? So 16 spaces, and we have to eventually occupy 12 of them, and then there's going to be 4 vacant. And what we want is for NTM to be able to park her SUV, and that is possible if you have 2 adjacent spaces. If that is the case, she can park. All right, so let's talk about this. From the 16 available spaces, there are 4 vacant spaces that we can choose from. So 16 choose 4 is going to give us the total number or possible combinations of choosing 4 vacant spaces from 16 spaces. So just keep that in mind. The next thing I would like to discuss is 2 things. The first is the probability that they want, and then the second is the opposite probability. The probability that they want is so that she can park. So that she can park. All right? Now the probability that I'm going to calculate initially is the probability that she can't park. All right? And I'll call that P. And then to figure out the probability that she can park, it's just 1 minus P, right? There's only 2 scenarios. One scenario is that she can park, and the other is that she can't park. And both of them added together would equal 1. Now, what would happen, or what needs to happen so that she cannot park? Well, that would basically mean that no 2 adjacent spaces are vacant. So that's what we'll do. We'll concentrate first on P. Once we find P, we can just subtract it from 1 to get the probability that she can park. All right, so here we go. So first, let's just illustrate 12 cars parked in a row. So these 12 cars labeled C, I've labeled them 1 through 12, and we want to initially create a scenario where there's no 2 adjacent vacant spaces because we want to initially calculate P. So where do we put in the vacant spaces? The vacant spaces can go either here, here, or here, like in the middle. And if I put those vacant spaces there, then I can create this scenario. All right? So how many of these spaces are there? Well, there's 12 cars, but if you count these little arrows that I just drew in, there's 13 of those arrows. So from those 13 positions, I've got to choose 4 vacant spaces. And how do we do that? We're, again, using choose notation. From 13, choose 4. And there you go. Now, I'd like to explain that a little bit more because some of you might get a little confused. So I'll give you an example. For example, what was something that will work and what is something that does not work? So let's say I want to follow this scenario. From 13 positions that I have illustrated here, I want to choose 4 vacant spots. So I'll do that right here. Okay, no problem. And any example is fine. So I'll put 1 vacant spot here. I'll put 1 here. And then I'll put, let's say, 1 here and 1 here. Okay? So does this satisfy what I want? That we want no 2 adjacent vacant spaces? Yeah, it does. No 2 adjacent spaces are vacant. But now I'm going to create a scenario that does not work. So for example, if I put V here, but then I put 2 V's together. So something like this, V, V. And then I put a V, let's say here. This does not satisfy this. We want no 2 adjacent spaces together. So I wanted to illustrate that to show that 13 choose 4 is the only way to make it so that there's no 2 adjacent spaces together. All right? So if that is clear, we move on with P. P is the probability that she can't park, and that would be 13 choose 4 all over 16 choose 4. Okay? 13 choose 4 is what we have done up here. It's the way of creating a scenario where there's no two adjacent vacant spaces. And we have to divide that by the total number of ways of putting 4 vacant spaces among 16 parking spots. So if you do the math here, this comes out to 11 over 28. All right? I'll let you do that whole choose notation. Now, that's not the answer to the question, right? Because we don't want that. We want this right here. We want the probability that she can park. How do you get that? Well, it's 1 minus p. And if you do 1 minus p, that would be 17 over 28. And that is the answer to this question. So 17 over 28 is answer choice E. The sum of the base 10 logarithms of the divisors of 10 to the power of n is 792. What is n? So let's start off with a very basic example to illustrate what this question is talking about. So for example, let's say n was equal to 2. Okay? So that would mean we have 10 to the power of 2. 10 to the power of 2 is 2 times 5 to the power of 2. Okay? And that means that's 2 times 2 times 5 times 5, right? Now we have to figure out the divisors of that. So let's see here, that would be 1, 2, 4, 5, 25, 10, 20, 50, and 100. So we've got 9 divisors. Then if this question was that n is 2, what we would do is we'd take the base 10 logarithms of each of these divisors. So it would be something like this. And then we'd add them up, right? Because it's the sum. So it would be the log of 1 plus the log of 2 plus the log of 4 and so on. You add them all up. And I didn't write in the base 10. In logs, if you don't write a base, it's assumed that it's base 10. Just saves us a little bit of time. And then, as you know from the log rules, when you have a whole bunch of logs that have the same base, you can just multiply them all. So I'll put in the log 10 now, but you're multiplying all of these guys, so it's 1 times 2, like that. And if you multiply all these guys, you get 1 billion, right? And 1 billion is 10 to the power of 9. So it's 10 to the power of 9 to the base 10. And log rules, you could put the 9 out front. And this just gives you log of 10 to the base 10. And we know that that's 1. So that equals 9. So in this question, when n was equal to 2, our final answer is 9. What they're saying is that instead of n equal to 2, they're just giving us n. And they're saying that when you do this big long scenario, instead of getting 9, you're going to get 792 and find out the value of n. Okay? So I hope this makes sense. If this makes sense, then we move forward with the rest of the question. So here we go. So we have not 10 to the power of 2 this time, we have 10 to the power of n. And as before, I just break it up into 2's and 5's like that. And this is 2 to the power of n times 5 to the power of n. I'll use a capital N. For some reason, it's easier for me to write. Now, as before, I have to figure out the divisors of 10 to the power of n. Now, obviously, I don't know what n is, so I can't write them all out, but I can write a pattern. So, for example, it will be 1, 2, 2 to the power of 1, 2 to the power of 2, and so on, right? 2 to the power of 3, dot, 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 all the way until 2 to the power of n. But we are obviously not done. We have to look at the 5's. It's 5, 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, dot, 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 all the way until 5 to the power of n. And of course, all the combinations. So 2 to the power of 1 times 5 to the power of 1, 2 to the power of 1 times 5 to the power of 2, 2 to the power of 1 times 5 to the power of 3. You get the idea. All the way down to 2 to the power of 1, 5 to the power of n. And similarly, 2 to the power of 2 times 5 to the power of 1, 2 to the power of 2, 5 to the power of 2, 2 to the power of 2 times 5 to the power of 3. and all the way down to the very end, which is 2 to the power of 2, 5 to the power of n. So you get the idea, right? And I'll just finish it off. This is going to be dot, 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 all the way down to 2 to the power of n, 5 to the power of 1. 2 to the power of n, 5 to the power of 2, 2 to the power of n, 5 to the power of 3, and so on, dot, 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 until we have the very last one, which would be 2 to the power of n, 5 to the power of n. Okay? So I instead of using summation, because a lot of times people just use summation, say n from 1 to n, and that's perfectly fine. In fact, it's mathematically accurate and appropriate, better even, than to write it all out like this. But the reason I want to write it out like this is because I want you to understand it. I don't want to just put in summation, because if I put in these summations, you might be able to understand it, but you might say, well, what does that mean? I don't understand. Where did you get that from? So that's basically the long version of writing this out. Okay, so far so good. The next thing, of course, as before, we had to take the logs of all of these, right? We have to take the log of all of these guys. So I'll write all of those out. And essentially, I just took the logs of all of these guys up here. That's all I really did. I didn't change anything. I just put dot, dot, dot to illustrate that there's quite a few in between. And they are telling you in the question, then when you do take the log of all of these divisors and add them, when you take the sum, that number is going to be equal to 792. Okay? Now, at this point, you think, well, okay, well, how do I proceed with this? This doesn't seem like it's going to be possible. And the good news is that it's very possible because we have a log rule, just like before. This is identical to my example before. The only difference is that this involves a lot more terms. What you do now, using log rules, is you just multiply them all. So instead of plus, 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 it's log to the base 10 of the multiplication of all of these. So I'll just write the first few. It would be 2 to the power of 1 times 2 to the power of 2, dot, 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 times 2 to the power of n. And then you just keep multiplying like that. 5 to the power of 1, 5 to the power of 2, dot, dot, dot. These are all multiplications. 5 to the power of n. See what I mean? So I'll write those all out. And that entire is going to be equal to 792. All right, so now is when, in my opinion, we get to the heart of the question. Now this whole thing is, if you look at log rules, 10 to the 792 is equal to this whole thing. Now instead of writing it out, I'm going to now start using the fact that we have to combine them all. So for example, all of these guys combine 2 to the power of something. Now what is that something? Well, it's 1 plus 2 plus 3 all the way up until n, right? Because you're going to add those exponents. 1 plus 2 plus 3 all the way up until n. If you remember, and if you're in grade 12 and you're taking math contests, you remember that formula is n times n plus 1 over 2, right? If you add the sum of consecutive integers from 1 until n. So that takes care of this guy. Now we got to look at that guy in a very similar way. That is 5, but the exponents, again, are adding 1 plus 2 plus 3 all the way up until n. So that's also n times n plus 1 all over 2, right? So far, so good. All right, keep going here. Now, the next few might get a little tricky, but they're actually not so bad. Now we're going to look at these ones right here. Those ones, all of them are 2 to the power of 1. So they're all 2 to the power of 1, 2 to the power of 1. But how many of them? There's n of those. So those 2's combine to give you 2 to the power of n, like that. But then the 5's, if you just look at 5 to the power of 1, 5 to the power of 2, all until 5 to the power of n, those are 5, and then the exponent will be n times n plus 1 all over 2. Okay? And now let's look at this one here. These guys. I'm doing this slowly because I really want you to understand it. Otherwise, what's the point, right? Here you got a whole bunch of 2 to the power of 2's. When you combine them all, there's n of those. So it will be 2 to the power of 2n. And then the 5's, 5, 1, 5 to the power of 2, 5 to the power of n, all the way up until 5 to the power of n. And that becomes 5, again, same thing, n times n plus 1 all over 2. And then we can jump to the very last one, which is right here. And that one, in a very similar way, we've got 2 to the power of n, 2 to the power of n, all the way to 2 to the power of n, but there's n of those. So it's 2 to the power of n times n, like that. And then the 5s, as before, nothing changes. It's just 5n times n plus 1 all over 2. And this whole thing is equal to 10 to the power of 792. All right? So far, so good. Okay, now we have to combine these. So we got 10 to the power of 792. And then here we've got, all right, so we have to start combining these. These two guys, since the exponents are the same, we can combine the bases. So 2 times 5 is 10, and it's going to be all n times n plus 1 all over 2. Now these guys, this is all multiplication, so I can combine all these 2's together. It's 2 to the power of n, then 2 to the power of 2n, and so on, right? So that basically becomes 2. If you factor out an n, it's 1 plus 2 plus 3 all the way up until n. So it's n times n plus 1 all over 2. Okay? And then finally, we got to combine all these guys. The good news there is all the exponents are the same. So it's just 5 times n plus 1 all over 2, since there was n of those. And that's it. That is the final expression. I mean, there's some basic simplification after this, but if you get to this point, that's great. You have pretty much understood how to do this. Now, as always, since these two exponents are the same, we can combine the bases. So we got 10 times n plus 1 all over 2, and then those two become 10 times n times n plus 1 all over 2, like that. And this is 10 to the 792. All right. Now at this point, we can again combine the bases. So this becomes 10. We can add those, right? So it's n times n plus 1 all over 2 plus n times n plus 1 all over 2. And that's 10 to the 792. And then now, of course, we can finally drop the 792 and just look at the exponents. And that's going to be, I can factor this, but let me just write it out first. Let me multiply through by 2. That way I can get rid of the fraction. And then now I'll factor. So I can actually factor n and n plus 1, because that's common to both. And if I do, I get 1 plus n. Okay, great. And that's it. Now at this point, we have to do this by, I think we have to do this by inspection. I mean, I guess I could multiply this all out, but if I do, I'm probably going to get n to the power third, and we don't want to deal with n to the power thirds. So you can just kind of fiddle around with the numbers. You can actually look at the answer choices. It wouldn't take you that long. The answer choices are, oh boy, where are we? Here's are the answer choices, right? Between 11 and 15. So looking at the answer choices, you can start plugging in to see which one works. Or you can just do it by inspection. You know, it's just n times n plus 1 times n plus 1, really. A is equal to 1584. And if you do, you will quickly realize that n is equal to 11. Because if you have 11 times 12 times 12, that is equal to 1584. All right? So there you go. That's the answer to the question. So number 23, the answer is A. Let A equal 0, 0. Distinct points A1, A2, dot, 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 lie on the x-axis, and distinct points B1, B2, and so on, lie on the graph y is equal to the square root of x. For every positive integer n, an minus 1, bn, an, is an equilateral triangle. What is the least n for which the length a0, an is greater than or equal to 100? So I will first draw the diagram, explain everything, and then we'll move forward with trying to figure out this length here and the value of n. So here is a very rough diagram and the graph of y equals the square root of x, okay? Don't worry about the accuracy of the graph. Just let's concentrate on the question. Now, what on earth are they talking about in this question, right? Some of the times on these harder questions, just understanding it is the hard part. Well, let's just work with what they give us. A0 is right here at the origin, and then along this x-axis, they've got A1, A2, and so on. A1, A2, I don't know where they are. We have to figure that out. And similarly, along this graph, they're going to have B1, B2, somewhere B3, and so on. But the biggest clue is right here, that for any triple of an minus 1, bn, and an, you're going to get an equilateral triangle. So that's a very big clue. So I'll just write a few of those, just like I guess 4 is enough. So when n is, for example, 0, my triple, this guy right here, is a0, b1, a1. Okay? When n is 1, it becomes a1, b2, a2. And I'll just put 2 and 3. That should be enough for us to understand this question. When n is 2, it's a2, b3, a3. And when n is 3, it's a3, b4, a4. Okay? These 4 triangles should be enough for us to figure this out. Now I got to draw these in. Okay? Here we go. Let's draw these in and start talking about this question. So let's draw in the first one. All right, so here we go. I just drew in some equilateral triangles, and let's start labeling this. This is going to be A1, this is A2, A3, and A4, and this keeps on going. This is B1, this vertex is B2, that's B3, and that's B4. All right? So this is the setup of the question. Now, what we are going to use to solve this is the fact that these are equilateral. And because they're equilateral, when you draw perpendiculars like that, all the way down, those are going to help us tremendously because those become 30, 60, 90 triangles, as always. This is 60 degrees, this is 90, and this is 30. And all of those have the same relationship. All right. So, if that is clear, let's begin. The first one, of course, is this triangle right here. Let's figure this out. So, this distance is a1 over 2, right? It's half of a1 from the origin. So, using 30, 60, 90 triangles, the ratio of this to the height, as always, I'll write it over here. I've got a little bit more space. The ratio is 1 to root 3, right? And of course, just for completeness, that will be 2, the ratio. So that means the ratio of this, which is a1 over 2, to the height is root 3 over 1. So root 3 over 1. Now, the base is a1 over 2. So that's pretty straightforward. But what is the height? Well, that is where this graph comes in. Remember, it's y is equal to root of x. So this point B1, the coordinates are of the form x root x, right? Because it's on this graph. Now, x in this case is a1 over 2. So the y-coordinate will be the square root of a1 over 2. Okay? And the y-coordinate represents that top to bottom distance, the height basically. So in this ratio, I will put the square root of a1 over 2 in the numerator, and then I solve for this. So a1 over 2 root is equal to root 3 a1 over 2. Take the square of both sides, and that gives me a1 over 2 is equal to 3 times a1 over 2 all squared. Divide both sides by a1 over 2, and if I do, I just get left with 3 a1 over 2, and then I can now solve for a1, and I get 2 over 3. All right, so that is my first value of one of these lengths. And in a very similar way, we're going to figure out this length, then this length, and that length. And then after we do those, we will see a pattern. And once we have the pattern, we can figure out what it is for any n. So I'll make that list over here. So far we have a1, 2 over 3, and we are going to do a2. But here's the thing. What's confusing in this question, or what's difficult in this question, in my opinion, is something that can become confusing. That is that we are really figuring out the distances of the bases. So this first one is that distance right there. So instead of calling it a1, I will call it distance 1. The next distance that I'm going to calculate is this distance right here. And then the next distance is that one, and then finally the fourth distance will be from there to there. Now you might say, well, why don't you just call them A1, A2, A3? And I'll explain why. Because A1 is from there to there, right? That's the same as D1. But A2 is the distance from the origin to A2. Do you see how that is different from D2? D2 is just that distance, the base of that triangle. And similarly, A3 would be the distance from the origin all the way till A3. I'm not calculating that distance, I'm calculating just that, which is the base of that third triangle. So I think that is a part of the question that can mess things up. Even if you understand it so far, that little part of the question can completely ruin your findings. And then once we have the first 4 distances, I can extrapolate and figure out a general formula for d to the n, and then I can figure out the full distance from AO to AN. And that will just be d1 plus d2 plus d3 dot 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 plus d4 all the way until dn. Okay, so that's how we're going to proceed. Now let's figure out this distance right here, which is d2. All right, just want to make that very clear. Okay, so same thing. It'll again be a ratio between this side and this side. And this side right here is equivalent to d2 divided by 2. So that will be in the denominator, like that. And that ratio, remember, it's root 3 over 1, the ratio of the height to the base of that triangle. So it's root 3 over 1. Now, what is the height? Well, that's where the point B2 comes in. Very carefully now, the x-coordinate is what? The x-coordinate is not D2. The x-coordinate is all the way from A0 to that point. So how do we figure that out? Well, it's going to be A1, the distance from there to there, which we already figured out was 2 over 3, plus the distance from there to there, which is D2 over 2, correct? Like that. And therefore the y-coordinate is the square root of that, because it's on this graph y is equal to the square root of x. Okay, so that's very important to understand. So this is what represents the height top to bottom. And that's what I put in the numerator here. 2 over 3 plus d over 2 squared, all under the square root sign. Okay, now I'll just do the first one, and then what I mean by that is solving this, and then the later ones I'll just let you solve it because the algebra gets kind of cumbersome. So first we cross multiply 2 over 3 plus d over 2 squared is equal to root 3 d2 over 2. Square both sides, and if you do, the radical disappears, and on this side we get 3 d2 squared over 4, like that. And then this actually becomes a very unfortunate quadratic. It becomes 3 over 4 d squared d2 squared minus d2 over 2 minus 2 over 3 is equal to 0. And then, of course, you can multiply through and get rid of the fractions and make it 9 d2 squared minus 6 d2 minus 8. And solving, you will get d2 is equal to 4 over 3. So we plug that over here, 4 over 3. So already you might be able to figure out a little bit of a pattern going on here, but I'll just do a couple more just for the sake of completeness. All right, moving right along. Now we're going to calculate that distance, which is d3 over here. Okay, so in a very similar way, we are going to compare that base to that height, and if we do, it is equal to root 3 over 1. All right, and that base is right there, which is d3 over 2. And the height, we have to do the same thing we did before, is figure out this coordinate right here. Well, the height is represented by the y-coordinate, but first we have to figure out the x-coordinate. The x-coordinate is all the way from there to there. So it's d1, which is 2 over 3, plus d2, which is 4 over 3, plus this, which is d3 over 2. Okay, and if you do that, you get 2 plus d3 over 2. And then the y-coordinate is just the square root of that. So it's the square root of 2 plus d3 over 2. And this represents the height, top to bottom, since it's the y-coordinate. So 2 plus d3 over 2. Okay, and like I said before, I will let you solve this. It's basically going to be solved in the exact same way as before. Solving, you will get d3 is equal to 6 over 3. So there we go. 6 over 3 goes over here. So by now, you probably have already concluded a pattern, but I'm going to do just one more just in case you haven't been able to figure it out. Last one involves d4, which is this distance right here. And as before, I'm comparing this base to that height, right? And if I do, that ratio will be root 3 over 1. Now, my b4 coordinate is very important. That is going to help me figure out what is the base. Well, the base all the way from there to there represents the x-coordinate. So that is d1, which is 2 over 3, plus 4 over 3, plus 6 over 3, plus d4 over 2, right? And that basically, if you do the math, it becomes 4 plus d4 over 2. And then therefore this is the square root of 4 plus d4 over 2. Okay, so that's what goes in the numerator and denominator. Here we got 4 plus d4 over 2. And then be careful, the that's the numerator, but the denominator is just this distance, which is d4 over 2. Okay, and solving this one, you get d4 is equal to 8 over 3. So we put 8 over 3 right here. So by now, I am certain that you can conclude what is dn. It will be 2n over 3. All right? So we are pretty much almost done. We just have to figure out our final piece of the puzzle, which is we have to figure out in this question, when is AO to AN greater than or equal to 100? And in particular, we have to find the smallest value of n for which this happens. Well, AO AN is equal to d1 plus d2 plus d3 all the way up until dn, dot, 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 like this. Well, d1, d2, d3, all that we just figured out. d1 is 2 over 3, d2 is 4 over 3, d3 is 6 over 3, d4 is 8 over 3, and in general, dn will be equal to 2n over 3, like that. And we want this to be greater than or equal to 100. So if I factor out a 2 over 3, this becomes 1 plus 2 plus 3 plus 4, all the way up until you have the value n, greater than or equal to 100. And this you can add up using our formula n times n plus 1 over 2. The sum of consecutive numbers is always going to be equal to that. And this is 2/3, greater than or equal to 100. And therefore, simplifying, this becomes n times n plus 1 is greater than or equal to 300. And at this point, you can quickly just use inspection. And if you do, to figure out that n has got to be greater than or equal to 17. So therefore, the smallest value of n that satisfies this is n equal to 17. And that is therefore the answer to our question. So number 24, the answer is C. Let ABCD be a trapezoid with AB parallel to CD. AB is equal to 11, BC is equal to 5, and CD is equal to 19, and DA is 7. Bisectors of angle A and angle D meet at P. Bisectors of angle B and angle C meet at Q. What is the area of hexagon ABQCDP? Our trapezoid looks something like this, right? This is A, this is B, C, and D. And then they've given us a lot of information. First of all, AB is 11, BC is 5, CD is 19, and AD is 7. All right? The first thing in this question that I'd like to do is figure out an altitude, or a height, I should say. And that is, of course, from top to bottom like this. And I'll just draw the same thing on the other side, starting from B. And since these are heights, they will meet the bottom at right angles. And this will allow me, hopefully, to calculate the height. So I'll label the height H, and here we go. So this distance from there to there, I don't know, so I'll just call that X. And this distance from there to there, I don't know, so I'll call it Y. Now, very quickly, I noticed one thing is that this is 11. Since they tell you that AB is parallel to CD, this distance is 11. So if that distance is 11, that means that 11 plus X plus Y is equal to 19, right? And that means X plus Y is equal to 8, and therefore Y is equal to 8 minus X. So that's a little bit more beneficial to us since we only have to deal with one variable. All right, now we've got two Pythagorean relationships, there and there, so let's go. The first one, we've got h squared plus x squared is equal to 7 squared. this triangle right here. In the second one, we get h squared plus 8 minus x squared is equal to 5 squared, like that. All right, so that's equation 1 and 2. I'll call this one equation 1. I'll call this equation 2. And then, since we have two equations, two variables, we can solve for x and y. Or x and h, I should say. You can solve for y too if you'd like. So, many ways of doing this. I'm just going to subtract this. I think that should be sufficient. Immediately, it'll get rid of the 8 squares. So, I got x squared. Let's expand that. So, that's going to give me minus 64. I'm subtracting. Plus 16x minus x squared. And then the other side was 49 minus 25. So, this just gives me 16x is equal to 49 minus 25 plus 64. And solving, I get x is equal to 5.5. Or if you want to write it out as 11 over 2. Either way. If you want to solve for y, you can. It'll be 2.5 or 5 over 2. But what we really want is h. H, plug it back into any of these. And you get, let's see here, 49 minus x squared, so 11 over 2 squared, like that, is h squared. So this becomes 49 minus 121 over 4, again a common denominator, 196 minus 121 over 4, and that is going to be 75 over 4 is 8 squared. And therefore, h is going to be the root of that, which is 5 root 3 over 2. So that is a very important finding. We just found the height. So that is the first part of this question. The next part of the question involves the same diagram, of course, but we're going to look at it in a slightly different way. Now let me explain what's happening here. This is my top to bottom h that I just figured out, but instead of calling it h, I'm going to call it x and x. Okay? And then the distance from P to AD is also going to be x. Now I'll explain why. And the same story holds true here. Now remember, what was P and Q? If you remember back to the original question, what they did was they took angle bisectors from A and another angle bisector from D and said that the point where they meet is P. That's what P is. Similarly, on the other side, they took an angle bisector of B and an angle bisector of C, and they said that the point that those angle bisectors meet is Q. All right? And our goal at the end of the question is to figure out the area of the shape ABQ CDP. That is our goal. So ABQ CDP. That shape is what we have to figure out. Well, I'm sure you can see that shape can be figured out with the following equation. It would be the full trapezoid ABCD minus those two triangles, right? If you subtract from it this triangle right here, which is BCQ, and this triangle right here, which is ADP. If you do that, you'll be able to get the area of that shape. So that is our goal. Now let's turn back our attention to these x's. How do we know this, first of all? We can label it, but how do we know that is true? Well, it's true because by definition, when you have angle bisectors, they're always equidistant from the sides of the angle. And that is a very important point that I think is challenging. A lot of people may not know that, or if they do know it, may not recognize it in this question. So based on that principle, P will be equidistant from AB, it will be equidistant from a CD and from AD. And that is why we were able to put x's there, since P is equidistant from those three sides. Okay, and in a very similar way, we'll label the same kind of story over there for Q. All right, great. Now we can use this formula to figure out our question. So we've got ABQ CDP is equal to ABCD minus BCQ minus ADP. Well, ABCD, if you remember the area of the trapezoid, it will be 11 plus 19, right? That side plus that side, divided by 2, times the height. And the height we figured out up here is 5 root 3 over 2. So that's very important. And then BCQ, the good news is we figured out that that is a right triangle, because if something is equidistant and you draw a line from it to the other side, it's the shortest possible distance, which is a straight line that's perpendicular, and that's why that's a right angle. So this was a very important point that we had to recognize to solve this question. So that just becomes 1/2 base times height. The base is 5 and the height is x. Now x is h over 2, right? If you look at that diagram, you'll be able to notice that. So I'll just put h over 2 right there. And then similarly, ADP, which is right here, ADP, that's also 1/2 base times height. The base is 7, and the height is x, which is h over 2. So there we go. This is what we are going to solve. So this gives me 15 times 5 over 2 root 3. This gives me 5 over 4, and h was equal to 5 root 3 over 2. This is going to give me 7 over 4, and h, which is 5 root 3 over 2. Okay, looks like there's 5 root 3's over 2 everywhere, so I can factor them out, make the math easy. And this gives me just 5 minus 5 over 4 minus 7 over 4. 5 root 3 over 2. And this looks like it's, make this a fraction, so 60 minus 12 over 4. And that looks like 48 over 4, which is 12. So 5 root 3 over 2 times 12. And that's going to be 6 times 5, which is 30 root 3. And there you go. 30 root 3 is the answer to this question. And that would be, for number 25, choice B.